All right, day 3 of area and perimeter. I'm going to deal with square roots again. The square roots are probably the toughest thing to deal with in this section. You may have to add them, you may have to multiply them, and you need to know how to do both. So when would that happen? Well, first of all, I just said we're dealing with square roots for area and perimeter, and then I split it up in 2 parts here. So when you're trying to find an area of a shape, you're going to have to multiply. Area is all about multiplying, and when you're trying to find the perimeter, you got to add up the outside edges, so you're going to have to add. So you might run into square roots for either one of these. You might have to multiply square roots, you may have to add square roots. So let me give you the once over on how to do that. This shape right here is a parallelogram. A parallelogram is basically a rectangle that got stepped on and started to fold to the side. All right, it's leaning, kind of like you've seen a cardboard box that used to be nice and rectangular, and then it gets old and it starts to lean over. It starts looking like a parallelogram. The reason I tell you this is because the area of a rectangle is length times width. I think you all know that. You've all been solving for area of a rectangle for a long time. Well, try and think of length times width as actually the base times the height. If you do that, then the formula for area of a parallelogram is going to make a lot more sense. Because the height of a rectangle is the side of the rectangle because it's going straight up. Now, once that rectangle gets stepped on and starts to lean, it becomes a parallelogram. Now, the height of the parallelogram is not the side anymore because it's not going straight up. If you want to measure the distance or how tall something is, you measure straight up. You don't stand against the wall and put the tape measure way out in the middle of the room and measure to the top of your head. You don't measure at an angle, you measure straight up. So if we want to measure how tall this parallelogram is, we need to draw a line in the middle of it going straight up, and that's the height. So as your box is leaning, the height is getting shorter and shorter and shorter. So the parallelogram actually has a smaller area than a rectangle, even though it's the same box. Okay, so the area of a rectangle is base times height. The area of a parallelogram is also base times height. You're just not using the side as the height because that's at an angle. You're using this line that goes straight up and down. All right, so here I give you a hypothetical parallelogram that has a base of the square root of 45 and the height of a square root of 5. So you multiply those two numbers together, just like you would if they did not have a square root symbol by them. 45 times 5, base times height, length times width if it's a rectangle. And you multiply those together, 5 carry the 2, 225. So you get 225. But since these are square root numbers, not regular numbers, it's the square root of 225. So the area of that parallelogram is the square root of 225. And now you hope that that's a perfect square. You can actually take the square root of that. And in this case, it is. The square root of 225 is 15. So the correct answer for that problem is 15. The area of that parallelogram is 15. It's the square root of 225. So you can multiply square roots just like you would multiply regular numbers. You just make sure you keep your answer after you multiply underneath the square root and then take the square root of that number. Okay, when it comes to adding, you cannot add square roots if they're not the same number. So here's a triangle that has 3 sides labeled, square root of 15, square root of 20, and 6. And I want to know the perimeter of that triangle. You have to add those 3 things together. So that's 6 plus the square root of 15 plus the square root of 20. And that's it. That's the answer. Those are not like terms. You cannot add those together. This does not become square root of 21. No, can't add a whole number with the square root. More common mistake is people make this the square root of 35. Can't do that either. Can't add square roots together if they're not the same number. So you get off easy. If they're all different, you just write them down with plus signs and you're done. That's the answer. If they're the same, then you can add them. So let me write what I originally had here, a square root of 15. Now you've got 6 plus the square root of 15 plus the square root of 15. You could think of that as kind of like 6 plus x. You would simplify that into 6 plus 2x because you have two x's. You could do the same thing with your square roots of 15. Since you have 2 square root of 15, this becomes 6 plus 2 square root of 15s. All right, you still don't technically add them together and make it a square root of 30. It's more like combining like terms. These are like terms, and you have 2 of them, so it's 2 square root 15. When that was a 20, those were not like terms. You could think of like the square root of 15 as the x and the square root of 20 as the y. You don't add x and y together. They're not like terms. So adding square roots is like combining like terms. They have to be the same. Multiplying square roots is just like regular multiplying. Keep your answer in a square root symbol. I think that's everything you need to know about square roots. I've spent all 3 lessons this week talking a little bit about square roots. So hopefully you feel halfway decent about square roots. Now, the one shape that I've talked about in class, but for those of you at home have not gotten, is a trapezoid. And this is the area formula for a trapezoid. 1/2 height times the quantity of B1 plus B2, which looks like a bunch of gibberish. So let me explain this to you. Here's a trapezoid. B1 and B2 stand for base 1 and base 2. Basically, B1 is the bottom of the trapezoid and B2 is the top. So this would be your B1 and this would be your B2. And then the height, just like a parallelogram, is not the length of the side because you don't measure height at an angle. You measure height going straight up and down. So that would be your height. So if I put numbers to these, let's say the bottom has a length of 12, the top has a length of 8, and the height is 4. Then you would add 12 and 8 together, the top and the bottom, the B1 and the B2, and you would get 20 for that in your parentheses. And then you would take half of your height is 4, half of 4 is 2, so you'd do 2 times 20 and your area is 40. So not too bad. The formula looks a little weird, but it's really just 3 numbers, the top, the bottom, and the height, which you use half of that length. And you multiply those together, you get 40, bada bing, bada boom, you're done. All right, let's say you had to find the perimeter of this shape. If you're looking for the perimeter of this shape, you are not going to use the height because that's in the middle of the shape. Perimeter is the outside. So when it comes to the perimeter, you do need to know the lengths of these diagonals because that's the outside of the shape. We're still going to use 12 and 8, so the perimeter is going to be 20 plus something, whatever these 2 sides equal. And chances are those 2 sides are going to be square roots because very rarely is a diagonal a perfect square. It's usually in between like 25 and 36 or in between 36 and 49. There's lots of numbers in between perfect squares. There's only a few that are perfect squares. So let's assume that they're not perfect squares. Now it's just like that triangle example. If you have square root of 17 and square root of 30, then your answer is plus the square root of 30 plus the square root of 17. And you can't combine those, and that's it. You're done. That's your perimeter. That's your answer. If they happen to be the same number, so let's say this is square root of 30. Now you can combine those just like you did on the triangle, and you'd end up at 20 plus 2 square root 30. All right, and sometimes it'll get really weird where this might be like 2 square root of 30, and this might be, say, 3 square root 30. You could still add those together, but instead of having 1 of each, now you've got 3 square root 30s here, and you've got 2 square root 30s here, so you have a total of 5 square root 30s. The square root 30, remember, is just basically like an x. It's like a variable. You just treat it like a variable. If they're the same, you can add them together. If you have 2 here and 3 there, you've got 5 total. So there you go. That's all the shapes. That's square roots. You know how to find the diagonal. You know how to find the length between 2 points that are on a grid that are diagonal from each other. I think you have everything you need to know. You should be prepared for the 5 questions that you're going to see on the benchmark, and hopefully I'll find a little bit of time to give you a quick review on the other standards that we did earlier this year.